Hello, friends. Disclaimer. As an Amazon associate, I earn from qualifying purchases at no additional cost to you. Please don't forget to check out product links for stargazing in the description of the video. The Great Red Spot is a vast, high-pressure region in Jupiter's atmosphere, creating an anticyclonic storm that rotates counterclockwise. First observed in the 17th century by astronomers like Robert Hooke and Giovanni Cassini, this storm has become one of the most studied atmospheric phenomena in our solar system. Jupiter's atmosphere, composed mainly of hydrogen and helium, with traces of methane, ammonia, and water vapor, is incredibly dynamic. The interplay of these gases under Jupiter's intense gravitational pull creates complex weather systems, giving rise to storms like the Great Red Spot. Located in the southern hemisphere, the storm's characteristic reddish hue is thought to result from chemical reactions in the upper atmosphere, possibly triggered by sunlight or cosmic rays. Jupiter's atmosphere is characterized by intense turbulence, with strong winds, lightning storms, and jet streams that run parallel to its equator. These jet streams, which can reach speeds of up to 400 miles per hour, create the distinctive striped appearance of Jupiter and play a crucial role in sustaining storms like the Great Red Spot. Unlike Earth, Jupiter has no solid surface, which means that storms can persist for centuries without losing energy. The planet's rapid rotation also contributes to the stability of these storms, including the Great Red Spot, by creating strong Coriolis forces that help maintain the storm structure. Over the past century, astronomers have observed a significant reduction in the size of the Great Red Spot. From a diameter of approximately 25,000 miles in the late 19th century, it has now shrunk to around 10,000 miles. This contraction has raised questions about the future of the storm and what might be causing it to shrink. Several theories have been proposed, including the possibility that smaller vortices and turbulence in Jupiter's atmosphere are draining energy from the storm, causing it to weaken. Another theory suggests that the Great Red Spot is simply going through a natural life cycle, where it expands and contracts over time in response to changing atmospheric conditions. NASA's Juno mission, which has been orbiting Jupiter since 2016, has provided unprecedented insights into the Great Red Spot and Jupiter's atmosphere. Juno's sophisticated instruments have allowed scientists to peer deep into the storm, revealing its complex structure and behavior. Data from Juno has shown that the Great Red Spot extends far deeper into Jupiter's atmosphere than previously thought, possibly reaching depths of up to 200 miles below the cloud tops. This discovery has added new layers of complexity to our understanding of the storm, suggesting that it is not just a surface phenomenon but a deeply rooted feature within Jupiter's atmosphere. As the Great Red Spot continues to shrink, its future remains uncertain. Will it eventually disappear, or could it stabilize at a smaller size and persist for many more years? Some scientists believe that the storm could dissipate entirely within the next few decades if its current rate of shrinkage continues. Others suggest that it may stabilize at a smaller size, continuing to be a prominent feature on Jupiter for centuries to come. The possibility of new storms forming on Jupiter, potentially even larger than the Great Red Spot, cannot be ruled out, adding another layer of mystery to the future of this iconic storm. The Great Red Spot on Jupiter and the Great Dark Spot on Neptune are two of the most significant storms in our solar system, but they differ in many ways. The Great Red Spot has been raging for at least 350 years, making it one of the longest-lasting storms ever observed. It is characterized by its deep red color and powerful winds, which can reach speeds of up to 400 miles per hour. In contrast, Neptune's Great Dark Spot, discovered by the Voyager 2 spacecraft in 1989, appeared suddenly and disappeared within a few years. This transience suggests that Neptune's atmospheric dynamics are quite different from those on Jupiter, with storms forming and dissipating more quickly. The Great Dark Spot was smaller than the Great Red Spot, approximately the size of Earth, and had even stronger winds reaching speeds of up to 1,500 miles per hour. The key difference between these two storms is their stability, with the Great Red Spot persisting for centuries, while the Great Dark Spot was short-lived. The differences in their appearance, with the Great Red Spot's reddish hue and the Great Dark Spot's dark coloration, are also notable, reflecting the distinct atmospheric compositions and conditions on the two planets. The Great Red Spot has inspired countless stories in science fiction and popular culture, symbolizing the immense and mysterious forces at work in our solar system. In literature, the storm has been portrayed as a gateway to other worlds or as a central element in tales of space exploration and alien life. One of the most famous examples is Arthur C. Clarke's, where Jupiter and its moons play a key role in humanity's quest for knowledge. While the Great Red Spot itself is not directly featured, the planet's mysterious nature and the idea of unexplored territories resonate throughout the story. In films, the Great Red Spot often serves as a dramatic backdrop for space adventures, emphasizing the awe-inspiring and dangerous nature of the cosmos. For instance, in the storm's swirling patterns and turbulent atmosphere are depicted as both beautiful and menacing, adding to the film's visual impact. The storm has also influenced various forms of art, from paintings to video games, where it is often used as a metaphor for chaos, power, and the unknown. In video games, the Great Red Spot is sometimes featured as a challenging environment for players, emphasizing the theme of overcoming great odds in a hostile universe. Its presence in popular culture underscores its status as an iconic feature of our solar system, symbolizing the vast, unexplored regions of space and the potential for discovery. Jupiter's Great Red Spot, the largest and most recognizable storm in the solar system, has intrigued scientists since it was first observed centuries ago. Recent research, including simulations and data from space missions like Juno, has explored its formation, stability, and the possibility that it could eventually shrink or disappear. The Great Red Spot is a giant vortex that has persisted for at least 190 years, possibly longer. Recent studies suggest that it is distinct from an earlier observed spot, known as the permanent spot, which may have disappeared sometime between the mid-18th and 19th centuries. The Great Red Spot has been shrinking over time, and future research will focus on its sustainability and potential disintegration. The Great Red Spot is easily recognizable due to its reddish hue, which contrasts sharply with Jupiter's pale cloud tops. Even small telescopes can capture its distinct appearance. The storm is a gigantic anticyclonic vortex, with winds reaching speeds of 450 kilometers per h along its outer edges, making it the largest and longest-lasting vortex in the atmospheres of any planet in our solar system. However, the exact age of the Great Red Spot is still debated, and the processes behind its formation remain a mystery. Speculation about the origin of the Great Red Spot dates back to the first telescopic observations made by Giovanni Domenico Cassini, who in 1665 discovered a dark oval at the same latitude as the Great Red Spot and named it the permanent spot. This feature was observed until 1713, after which it was lost for 118 years. It wasn't until 1831 that S. Schwabe observed a clear structure, roughly oval in shape, at the same latitude as the current Great Red Spot. Since then, the Great Red Spot has been observed regularly, both by telescopes and by space missions visiting Jupiter. Recent studies have analyzed the Great Red Spot's evolution, its size, structure, and movements, using historical sources dating back to the mid-17th century. From these measurements, it is highly unlikely that the current Great Red Spot is the same as the permanent spot observed by Cassini. The permanent spot likely disappeared, while the Great Red Spot has continued to evolve over at least 190 years. To the north of the Great Red Spot, winds blow westward at 180 kilometers per h, while to the south they blow eastward at 150 kilometers per h, generating a huge north-south shear in wind speed. This shear is a key ingredient in the vortex's growth. The researchers explored different mechanisms to explain the genesis of the Great Red Spot, including the eruption of a gigantic superstorm or the merging of smaller vortices. However, the simulations indicated that these scenarios do not fully match the properties of the current Great Red Spot. Another set of numerical experiments examined the possibility of the Great Red Spot forming from an instability in Jupiter's winds, creating an elongated cell that eventually shrinks into the compact, rapidly rotating storm observed today. The formation of such elongated cells has been observed in the genesis of other major vortices on Jupiter. The researchers discovered that these cells are stable when they rotate around the periphery of the Great Red Spot at the speed of Jupiter's winds. Future research will aim to reproduce the shrinkage of the Great Red Spot over time to better understand the physical mechanisms behind its sustainability. The goal is to predict whether the storm will eventually disintegrate, as might have occurred with Cassini's permanent spot, or whether it will stabilize at a smaller size and continue to persist for many more years. Jupiter's Great Red Spot is more than just a storm. It is a symbol of the incredible forces at work within our solar system. From its mysterious origins and dynamic atmosphere to its influence on science fiction and popular culture, the Great Red Spot continues to captivate and inspire. As we study this colossal storm, we are reminded of the endless possibilities for discovery and the profound impact such phenomena have on our understanding of the universe. While the future of the Great Red Spot remains uncertain, its legacy in both science and culture is assured, making it an enduring icon of the mysteries that lie within our solar system. If you're ready to take your stargazing experience to the next level, check out the telescope and binocular links in the video description below. As an Amazon associate, I earn from qualifying purchases, but it won't cost you a penny extra. Thank you for joining us on this journey through Jupiter's Great Red Spot. Please like, comment, and share the video, and please do not forget to subscribe for more videos.